Chapter 8, Science, Math, and Medicine. Before the 6th century BCE, the gods were considered responsible for things like illness and death. If someone experienced misfortune, surely they have offended the gods. If the seas raged, someone must have angered Poseidon. But over time, the ancient Greeks changed their way of thinking and interpreting the world. They discovered explanations for events they had previously attributed to the gods. Their inquiring minds and interest in how the world worked led to some impressive scientific discoveries and inventions. Although the ancient Greeks continued to believe in the gods, they began to understand natural causes. Science, the act of learning about the world through observation, identification, and experimental investigation, became an important part of ancient Greek life. Greek scientists explored the properties of matter, developed theories about atoms, studied anatomy, and created medicine. They discovered and improved upon methods for moving cumbersome and heavy items such as ships, building materials, and statues. They even made an ancient computer. Words to know. Science, the study of the physical and natural world using observation and experiment. Properties, a quality or feature of something. Matter, any substance that takes up space. Theory, an idea about something that explains why something is the way it is. Atom, the most basic, smallest particle of matter. Anatomy, the branch of science that studies the body. Simple machines. There are 6 types of simple machines: the lever, the wedge, the pulley, the wheel and axle, the inclined plane, and the screw. These simple machines were used long before people in ancient Greece began experimenting with them, but the curiosity of those ancient Greeks led them to use these simple machines to create more complex machines. One Greek famous for his inventions is Archimedes. Considered one of the greatest mathematicians of all time, Archimedes used his knowledge to invent devices like the Archimedes claw, a catapult, and the Archimedes screw. Archimedes' inventions were inspired by his desire to solve the problems that people of his time faced every day. During a visit to Egypt, Archimedes invented his endless screw to help peasants bring water from the Nile to irrigate their fields. He improved upon early water clocks by adding gears that showed the moon and planets in orbit. Water clocks are clay vessels made to slowly leak water, thus marking the passage of time. Archimedes also invented numerous weapons. These were used in defense of his birthplace, Syracuse, a Greek colony on the Italian island of Sicily, against the Romans. Archimedes. A classical computer. Among the most fascinating creations of ancient Greece is a complicated, computer-like device that was found by divers in 1901 off the southern tip of mainland Greece. The dials, gears, and inscribed plates were badly corroded after 2,000 years underwater, but scientists believe that the device used gears connected to a hand-driven axle to mimic the movement of the sun, moon, and planets. In other words, the Greeks had created an analog computer of sorts for tracking the movement of heavenly bodies. Named after the island it was found near, the Antikythera mechanism remains something of a mystery. Nothing similar has been found. Knowing that the Greeks had such complex mechanical skills, however, makes scientists wonder what other surprises might be hiding beneath the waves. The war weapons of Archimedes included catapults and the claw, a crane-like machine that lifted enemy ships out of the water and onto the rocks. His mirrors could concentrate the sun's light on enemy ships, setting them ablaze. Did these inventions really work? Scientists have experimented with the Archimedes mirror and found that it might have worked if the targets were in close range. When working on a difficult problem, Archimedes often became so involved with his work that he would forget to eat. Atomic knowledge. Just as ancient Greek scientists wondered about the cause of illnesses, they questioned what the world was made of. They made many discoveries in physics, the study of matter and energy. Many Greek philosophers believed that the world was made of particles, though they didn't agree upon just how these particles worked. Some argued that there was a single basic element that made up the earth, while others thought there were more. Some thought that all of these particles were exactly the same, and others guessed that every substance had its own kind of particle. Words to know. Analog computer, a device that uses mechanical methods to model a problem. Physics, the scientific study of matter, energy, force, and motion, and the way they relate to each other. Around 400 BCE, a man named Democritus developed a theory about atoms. The word atomos means indivisible in Greek. He believed that atoms are so small that they are invisible to the eye, indivisible into smaller parts, solid with no empty space inside, and eternal because they are perfect. He also thought atoms were able to assemble in an infinite number of shapes. That's why the world has so many different objects in it. Know your ancient Greeks. Democritus, circa 470 to 380 BCE. Democritus is known mostly for creating the theory of atoms with his teacher Leucippus, but Democritus researched many other topics during his lifetime. Unfortunately, most of his writing was lost, but the works of other ancient Greeks shed some light on his accomplishments. He wrote about numbers, geometry, and mapping, and he was the first person to figure out formulas for the volume of a cone and a pyramid. Supposedly, he traveled to Egypt, Babylon, India, Persia, Ethiopia, and many other lands to meet other thinkers. In addition to exploring zoology, the study of animals, botany, the study of plants, and medicine, Democritus had big ideas about the structure of the universe. He thought that the Milky Way was made of stars that were so far away that they blended together from our point of view. He also suggested that stars other than the sun had their own planets, probably with other living beings on them. Life on other planets? That's a theory we are still trying to prove today. The Golden Crown. King Hiero II ruled Syracuse, a Greek colony on the island of Sicily, from about 270 to 215 BCE. During his rule, he commissioned a goldsmith to create a golden crown, likely for a statue of a god or goddess. The king gave the goldsmith a specific amount of gold to create the crown, but the king suspected that the goldsmith was deceitful and rather than crafting a solid gold crown, used less expensive silver to fill it. The crown, made in honor of the gods, was a sacred object and could not be melted down to check its purity. The king brought this dilemma to Archimedes and asked him to figure out whether he had been cheated. Archimedes wasn't sure how to tackle this problem until one day when he was taking a bath. He noticed that submerging his body caused the water to overflow. He figured out that the volume of water displaced is equal to the volume of the submerged item. With this knowledge, he devised a plan. Archimedes knew that silver weighs less than gold, so the goldsmith would have had to use a greater amount or volume of silver to make a crown that matched the weight of the original piece of gold. Archimedes filled a container of water to the brim and put the crown in the water to measure its volume. He then repeated the experiment with a solid piece of gold exactly the weight of the one King Hiero II had given the goldsmith. Archimedes discovered that the goldsmith, obviously less concerned with angering the gods than King Hiero II, had tried to trick the king by filling the crown with silver, thus making a dishonest profit. There is no record of what happened to the goldsmith, but you can be sure that King Hiero II was thankful for Archimedes' discovery. What's more, argued Democritus, atoms move around freely in an empty space. This movement of atoms explains why some objects are hard and some soft, why you can see fog yet put your hand through it. Democritus' theory of atoms is similar to our modern view of atoms, but today's scientists didn't get their understanding of atoms from the Greeks. In fact, we only know of Democritus' ideas because the Roman poet Lucretius wrote down the theory of atoms in the 2nd century CE, 500 years after Democritus died. Modern scientists believe that all atoms are the same, though they can differ in size and properties such as color, and when linked together can create different elements. Calculating Greeks. The ancient Greeks gave us a knowledge of physics as well as many of the mathematical theories and formulas we still use today. Knowledge about mathematics started out with the basics. Counting was likely created so that herdsmen could track their flocks of animals. We know this because archaeologists have found scratches carved in bones that are thousands of years old. It's hard to look at a bunch of scratches, though, and immediately see the difference between this and that, which is what led to the creation of numbers. Know your ancient Greeks. Pythagoras, circa 580 to 500 BCE. The first real mathematician to emerge in ancient Greece was Pythagoras of Samos. In fact, he and his students are thought to have been the first to use the term mathematique to mean mathematics. Before Pythagoras, mathema referred to any type of learning. Pythagoras focused on clear thinking through deductive reasoning, that is, using basic principles and general laws to figure out specific facts and solve problems. He was so devoted to the study of geometry and arithmetic that he opened his own school, which also taught music and astronomy. Students have to live by strict rules so that they could develop pure minds and bodies. One discovery that comes directly from Pythagoras and his students was the proof that the three angles of a triangle equal the sum of two right angles, 180 degrees. Pythagoras and his students developed very personal relationships with the natural numbers 1, 2, 3, etc. They thought of odd numbers as male and even numbers as female, and they described numbers as beautiful or ugly, perfect or incomplete. 10, for instance, was the best number because it was the sum of the first four numbers and could be written as dots in a pyramid to form a perfect triangle. Archimedes and Pi. Archimedes is the clever guy who discovered the famous number we call pi, 3.1416. We use pi to solve many geometrical math problems, such as the area, circumference, or radius of a circle. Though Archimedes gets the credit for discovering the exact number for pi, he wasn't the first person to try to calculate the ratio of a circle's circumference, the distance around a circle, to its diameter, the length of the straight line bisecting a circle through its center point. There is documentation that the ancient Egyptians, as far back as 1650 BCE, had approximated a similar, though less accurate number. The details of just how Archimedes figured out pi are very complex and involve lots of mathematical calculations. The number discovered by Archimedes around 250 BCE is still accurate today. Amazing. Circumference, radius, diameter. Different mathematical fields developed for various practical reasons. Geometry, for example, fulfilled a need for accurately measuring space. In the original Greek, geometry means measurement of the earth. Geometry may be a Greek word, but the study of measurement actually began in Egypt. Each year, the Nile River flooded, washing over the croplands, and each year, Egyptians had to map out the fields to reestablish where one farmer's field stopped and their neighbor's began. 800. All dates are BCE and approximate in many cases. Archaic period. Pythagoras, circa 580 to 500 BCE, loved numbers and was known as the first mathematician. 480. Empedocles, circa 490 to 430 BCE, used his medical knowledge to help his fellow citizens. Democritus, circa 470 to 380 BCE, developed a theory about atoms. Classical period. Hippocrates, circa 460 to 370 BCE, was called the father of medicine and developed a code of conduct still used today known as the Hippocratic Oath. 323. Archimedes, circa 290 to 211 BCE, was one of the greatest mathematicians of all time who put his knowledge to use creating useful inventions. Hellenistic period. 31. Geometry basics were brought from Egypt to ancient Greece by Thales of Miletus, who on his return to Greece further developed geometric theories. Thales went beyond asking how geometry worked and investigated why it worked. He realized that understanding how to measure croplands and lay out cities and palaces is useful, but that knowing the general rules of geometry is even more valuable because then you can measure anything. Words to know. Geometry, the measurement and relationships of points, lines, angles, surfaces, and solids from the Greek geo, earth, and metro, measure. Ancient remedies, healing from the heavens. According to Greek mythology, the centaur Chiron, half man, half horse, invented medicine so that he could heal himself after being wounded in a battle with the strong and courageous Heracles, son of Zeus. Chiron then taught the healing arts to the hero Achilles, whose mother dipped him in the river Styx, making him invulnerable to wounds, and to Asclepius, who was thought to be the son of the sun god Apollo. Chiron, Asclepius. A staff of snakes. Most ancient Greeks thought that snakes had healing properties, and Asclepius was always pictured with a snake wrapped around his staff. Why snakes? Perhaps because snakes shed their skins, which makes it seem like the snake is being reborn again and again. Today, the caduceus, a staff wrapped around two snakes, is a symbol used by many modern doctors, but the caduceus was originally a symbol of Hermes, the quick-footed messenger god. Asclepius only ever had a single snake by his side, and really isn't one snake enough for anyone? Know your ancient Greeks. Empedocles, circa 490 to 430 BCE. Empedocles was born into a very wealthy family in Acrogos, a Greek colony on the Italian island of Sicily. As a boy, he studied philosophy, natural sciences, and the arts. As an adult, Empedocles used his medical knowledge and wealth to improve the welfare of his fellow citizens. When a plague infected the city of Acrogos, Empedocles created a wall of animal skins to cover an opening in the city and divert the illness that was coming in on a polluted breeze. Later, in the neighboring city of Selinus, he diverted the course of two rivers to clean a polluted water supply and stop the spread of disease in the town. These accomplishments, as well as his writings on philosophy, made Empedocles quite famous, and he came to be treated something like a god. According to legend, Empedocles threw himself into Mount Etna, a volcano in Sicily, leaving behind one bronze sandal. A single bronze sandal was associated with Hecate, goddess of magic, and by leaving it behind, Empedocles indicated that he thought he was going to become immortal, a true god. In fact, Asclepius was a human who lived around 1200 BCE, but his medical abilities were so respected that he was thought to be as powerful as a god. According to one story, ancient Greeks overcame the pain of gout, a painful foot inflammation, by standing on electric eels until their feet were numb. Nearly every Greek town featured an Asclepion, a temple devoted to Asclepius where ailing citizens could rest, pray, sacrifice to the gods, and drink clean water. A sick person resting in the temple might either be healed by Asclepius or have a dream in which Asclepius would explain how the person could be healed. One story tells of a man with a nasty sore on his toe who dreamed that a serpent crawled into the temple and licked his toe. When the man woke up, his toe was cured. Greeks in the 7th and 8th centuries BCE knew a lot about anatomy, that is, the structure of the human body. Trainers at gymnasia knew how to treat injuries like sprains, fractures, and dislocations. Homer's Iliad describes bandage techniques, battlefield surgery, and the use of anesthetics, substances that numb part of the body, before almost anyone else performed these treatments. Gruesome lessons. As scientists became interested in medicine, they wanted to learn more about how the body worked on the inside. Without x-rays, the only way to see inside a human body was to dissect one. Some dissections were done on dead people or animals, but in other cases, a procedure called vivisection was used on condemned criminals. These criminals were cut open while they were still alive, allowing the surgeons to see the heart, brain, and lungs at work. Ancient Greece in the 3rd century BCE wasn't a good place to break the law. Beyond anatomy, though, ancient Greeks generally didn't have much medical knowledge. They couldn't treat a cold properly and didn't really understand how the body worked. If a wound got infected, their only solution was to call in the snakes. Hippocrates gets hip to medicine. Despite medical theories that no longer hold true, good medical schools did develop in ancient Greece during the 5th century BCE. One of the most important schools was located at Kos, an island in the Aegean Sea, and another at Cnidus, both near present-day Turkey. The schools offered classroom lessons, research, and apprenticeship programs in which students worked side by side with teachers. Students had to promise to help the sick, to love humanity as much as they loved their work, and never to take a patient's life. More than 2,400 years later, doctors and nurses still take a similar vow. We call that vow the Hippocratic Oath, after Hippocrates, the leader of the medical school at Kos. Hippocrates became known as the father of medicine. He wrote hundreds of papers on surgery, anatomy, diseases, treatment of illness with diet and drugs, and medical ethics, that is, the code of conduct that doctors should follow. He taught medical students to observe their patients carefully and record facts, a practice essential for good science. Even more importantly, he convinced most people that illness and disease had natural causes and weren't inflicted by angry gods. Know your ancient Greeks, Hippocrates, circa 460 to 370 BCE. Little is known about Hippocrates other than that he accepted money from patients in exchange for care, and he taught medicine at the school on the island of Kos. While his personal history may be a mystery, his influence on the world of medicine isn't. The Hippocratic Collection is a set of 60 medical textbooks that tell doctors how they should do their job. While Hippocrates didn't write every book, which is impossible since they were written over a period of 150 years, his method of practicing medicine is present on every page. In the book on epidemics, for example, the doctor learns to note specific symptoms in the patient on a day-by-day basis so that he can record the history of the illness. This practice will allow him to treat future patients better. In the book on forecasting diseases, the doctor learns what to look for in a patient: hollow eyes, cold ears, strange face color, so that he can ask the right questions. Another volume explains how to fix a dislocated shoulder and treat a bone fracture. According to Hippocrates, the earliest Greek doctors spent too much time on philosophy and not enough time looking at the patient and his symptoms and learning from previous experience. Thanks to the teaching of Hippocrates, the way that doctors treat patients changed forever. Activity: Stomachion. Archimedes explored the concepts of geometry by playing a game called Stomachion. Some records refer to this game as Loculus Archimedes, Archimedes' box. 1. Use the pencil to lightly mark your square into 1-inch grids. 2. Duplicate the image you see below using the grid to help you accurately place each line. Once you have the lines marked in pencil, trace the lines with a dark marker. Color the shapes in any manner you'd like. 3. Cut along the dark lines to create a 14-piece puzzle. 4. To play, use all of the shapes to create clever pictures like animals or structures. Supplies: a 12-inch square of poster board, pencil, markers, scissors. Activity: make an abacus. Keeping track of things in ancient Greece was more difficult than it is today because they didn't have a numbering system that worked well yet. While hands and fingers helped in counting, there were times when a quantity was too large to use this method. To help in keeping track of items, they used a tool called an abacus. Supplies: sturdy shoebox lid, ruler, hole punch, strip of sturdy cardboard about 1 inch by 15 inches, glue, about 10 wooden skewers 12 inches long, 70 beads. These must slide easily on the skewer. 1. Measure off and mark 10 equal increments along both long sides of the shoebox lid, making sure that the marks are directly across from each other. Punch a hole at each mark. 2. Cut the extra strip of cardboard to the same length as the shoebox lid. This will be glued into the lid as a divider. Punch holes in the strip of cardboard to align with those in the sides of the lid. 3. Glue the piece of cardboard into the shoebox lid about 2 inches from one of the long sides. Let the glue dry. The narrow section will be called the upper deck. The wider section is the lower deck. 4. Push a skewer through the first hole into the lower deck. String 5 beads onto the skewer. Continue pushing the skewer through the divider into the upper deck, allowing 2 beads before pushing the end of the skewer through the last hole. Continue in this manner for all skewers. Glue the skewers in place at the sides of the box. 5. To use your abacus, place it flat on a table with the lower deck closer to you. Push all the beads away from the divider. The beads in the upper deck are valued at 5. Those in the lower deck are valued at 1. To use the abacus to count, move the beads in the far right column toward the divider. When you count 5 beads on the lower deck, you will carry to the upper deck. In other words, you'll move the 5 beads back to the starting position and move one of the beads from the upper deck toward the divider. For instance, to count out the number 8, you will move 1 bead, 5, from the upper deck and 3 beads, 3, from the lower deck. Adding 2 beads will give you all the beads on the lower deck, so you'll move those bottom 5 back to the bottom and another from the top deck to the middle, which equals 10, or 5 plus 5. When you count both of the beads on the upper deck, reaching the number 10, you carry that information to the adjacent skewer, push 1 bead from the second column to the middle and both beads from the first column to the bottom. The skewer farthest to the right is the units or single digits column, the skewer adjacent to this, the tens column, the next, the hundreds column, and so on. Upper deck, lower deck, 1, 5, 3, 2, 7, 8, 6.